All right, Miss Anita, I'm back with my last observation. That makes me so happy, but so very sad. We'll be done working together. So here's my classroom. Everybody say hi, Miss Anita. All right, so we're gonna be going over some fluency work. We just started our division unit, and I'm gonna do my best to get the video in. I might be a little hoarse because I'm getting a little sick, but these guys are gonna be ready to work, and we'll get things taken care of. So, first things first, guys, can I have everyone stand up at your desk? Stand up at your desk. Now, I don't have my ball working right now. It's become deflated since it left our room in a mysterious manner. And so I'm not going to be tossing the ball around, but we're going to be just doing a group activity here. This is group counting. Can I have someone please read the expectations for our group counting? Miss Tessa. Okay, so the signal's going to be, we're going to count by each one of these numbers to the end, which have already been identified for us. You'll notice that it's going to be 10 units of each number, and then we're going to go down. I'm simply going to say stop. So it's going to sound something like this. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, stop. And then we're going to go from 20 down. We're going to do that for each one of these, not super quick, on pace together. So on the count of 3, we're going to count by 2s to 20, then stop, and then we'll go back down and then move to the next number. Are we ready? 1, 2, 3, 2, 4, 6, 8, 10, 12, 13, 16, 18, 20, stop. And then we're going to do the same thing down, starting at 20 this time. 1, 2, 3, 20, 18, 16, 14, 12, 10, 8, 6, 4, 2, 0. Stop. Gets a little tricky on the way back down, right? But on the way, this connection is for both multiplication going up and division coming back down. That's why it's super important that we're getting this practice, okay? We're going to start with 3s. It's going to get a little trickier. I know 2s and 5s are going to be easy. These 3s and 4s, make sure we're paying attention. So we're counting 3s to 30 on the count of 3. 1, 2, 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, stop. Now we're going to go back down, starting at 30 on the count of 3. 1, 2, 3. 30, 27, 24, 21, 18, 15, 12, 9, 6, 3, 0. A little tougher on the way down, I get that. Now we're going to do 4s. Going up. 1, 2, 3, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. Stop. Now, on the count of 3, we're going to head back down, starting at 40. 1, 2, 3. 40, 36, 32, 28, 24, 20, 16, 12, 8, 4, last one, guys, by 5s. This one's a little bit easier. We know all 5s end in 5 or 0. Starting at 0, or starting at 5, I should say. On the count of 3. 1, 2, 3. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, stop. And on the way down, starting at 50. 1, 2, 3. 50, 45, 40, 35, 30, 25, 20, 15, 10, 5, 0. Stop. Perfect, guys. That's what I'm talking about. Moving on to the next one. Now, I would like, at this point, I think that we can do this. Raise your hand if you'd like to try to do this mentally, without a whiteboard. Okay, so we're going to do that. I want to make sure that we remember what we're doing. So when we have a number, go ahead and have a seat, guys. I appreciate you guys looking here. When we have a number that can go into our large number, our numerator and denominator. That's new words that we're going to start introducing. All right, guys. And so our numerator is going to be our big number. Our denominator is going to be our little number. We want to know how many groups of our smaller size, our denominator, can go into our larger number, our numerator. When I ask you that, we get the answer. That answer is called the what? Starts with a Q. Do we remember from yesterday? Carter. Quotient. We know that we want the quotient, right? It's spelled kind of funny, looks kind of funny. We've talked about it. Hey, it looks like quotations when we're talking. But that's not what it is. It is definitely the quotient. When the smaller numerator does not go into the denominator evenly, there's going to be something extra left. What's that called? Carter's got it, but Izzy. It's called the remainder. Okay? So we make sure that we understand when this number does not go into it evenly, it is called the remainder. What I'm going to do for you guys up here, underneath each one of these, I would like you guys to create your own version of this. Only do it one at a time though, so make sure you're sticking with me. What we're going to do is we're going to create it together, erase it, and start with the next one. Okay? I want to do at least 4 or 5 of these. We don't have to do every one, but I want to do 4 or 5. So I would like everyone on their whiteboards to put down 6 divided by 2. I want it to look exactly like that. 6 divided by 2. Now, I want to walk around. We want to make sure everyone's doing it. 6 divided by 2. We'll try to make sure that whiteboard's on top of that desk. 6 divided by 2. Now, what I want you guys to be able to practice until it's mentally just instilled in your brain. We got it. Oh, it's too easy now, Mr. Hefner. I want you guys to practice using arrays. When we use an array, that is like a visual model, like our area models. When I do this, I know the width of my array should be what? Based on 6 divided by 2. Crosby. Not 6. The width of our array. The size of groups that we want to work with to get to the total. 2. So when I make an array for 6 divided by 2, I go 1, 2. In fact, sometimes I'll remind myself by putting a 2 right next to there. I go 1, 2, and then I just count the 6 by 2. 1, 2, 3, 4, 5, 6. When you draw an array, everybody's whiteboard should look like that. Right? Groups of 2s to 6. Then we count up how many groups of 2s we got. We got 1. We got 2. We got 3. Can someone please tell me what is 6 divided by 2? Miss Aubrey. 3. That's exactly right. 3. So our quotient would be 3. Is there a remainder? No. Every single one of those dots has made it into a group. 2 goes into 6 evenly, and it goes into it 3 times. Our quotient is 3. Now, I'm going to leave that up there. In fact, I'm going to put that right here. I want you guys to erase that. This time I'm going to walk around and see everyone do this next one. I want everyone to put down 15 divided by 2. Everyone put down 15 divided by 2. And then, I like that Mr. Haven's already on top of that. Then I would like everyone to create an array showing how to solve 15 divided by 2. Right? I'm going to give you guys a hint. We know that the width of our array is going to be our numerator, right? Nope, denominator. I apologize. I always get those backwards. So it should always be 2, just like we did 6 divided by 2. 1, 2. And we keep putting dots till we get to 15. All right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. I like to identify all my groups, and then I'm going to walk around to see how everyone else is doing. All right? When we make these arrays, it's easier to visually see the answer of these division problems. Make sure you're following along, Mr. Braxton. I know you're tired. I need you to hang with me. All right? We know once we're done with this, we'll have a little bit of free time before art. So make sure you're hanging with me. That's perfect. Well, it depends on you guys. Tomorrow, it's not Friday, so it's not going to be free time. It's going to be math free time. It will be free time, but I want you guys sticking with me. All right? We got to show Miss Anita we know how to do this stuff. Miss Abigail. And you know what, Miss Abigail, she raised her hand. I like that she said that. You know what, Mr. Hefner? Hey, I noticed that we have all these even groups of twos. We have one that didn't make it. We have a remainder. Someone raise their hand and tell me the quotient or the answer to this. Mr. Crosby? How many groups of twos do we have? 7. We have 7 groups of twos. That is our quotient. Someone tell me what's our remainder. Izzy, that hand I got it so fast. Our remainder is 1. All right? Fantastic. Go ahead and erase that 1. We're going to skip this row. We don't need to do 5s. 5s is a little bit easier. We're going to go to 4s. We're going to go to this row. The next one I want you to do. 16 divided by 4. We know if we're making arrays, guys. We know if we're making these arrays. We know we need to use our denominator. Right? So we look at that number. That number should be over here. Our 4, making our arrays. 1, 2, 3, 4. I'm counting to 4s till I get to 16. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm not circling that up now. You guys circle it up. I want to see what you guys get. Miss Tessa, that was fantastic. I like that you even put a little Q and a little R to let me know exactly what the answer is. Miss Blake. Yes, ma'am. I got it packed up here for you. So we'll get you that other marker. Ma'am. Slowly with your voice. Miss Chloe, I haven't heard from you yet. What is going to be the answer to 16 divided by 4? It's going to be 4. Our quotient is 4. 4 goes into 16 4 times. If we circle that up, like I've seen you guys do it, we see that our answer is 4. We take a look at that, and we ask ourselves, do we have a remainder here? Miss Abigail, do we have a remainder? No, we certainly do not. Our remainder is 0. There's nothing after our last group of 4. All right? I'm going to do one more on this page, and then we're going to get into our lesson. So, yes, ma'am. Very welcome. So, we come up here, and I would like everyone to do 33 divided by 4. In fact, I'm going to come put it up here so we can see it a little bit better. 33 divided by 4. That's the last one on here. It's a little bit bigger, and I would like everyone to have an opportunity to create an array model that's a little bit bigger. It does not matter how large the number is. We can take our time and knock it out using the visual aid of an array. All right, this is the last one we're going to do on this, and then I'm probably going to get you guys to the carpet with your whiteboards, okay? You're doing great, Mr. Braxton. Staying with us. Last one over here, okay? 33 divided by 4. I'm going to start making the array. I see you guys already doing fantastic work. So I'm going to put the 4 over here to remind myself. I want it in groups of 4. 1, 2, 3, 4. I see some fantastic work, guys. So, since this is our last one, I'm going to let you guys give me all the answers. I'm not circling any of those groups. You guys tell me. Mr. Haven, I've been seeing you do some fantastic work over there. Do you have the answer? Oh, not yet. So this one. So, what haven't I heard from yet? Mr. Henry, when we come up here and we see how many groups of 4, how many whole groups of 4 we can get out of 33, how many can we get? 7. Ooh. When I look up there, I'm going to count. Let me check. And that was 1, 2, 3, 4, 5, 6, 7, 8. Very close. Very close. We will get 8. Now, one thing that I like to remind you guys, after you get your answer, you can check it. First, we'll get our answer and see if we're right. Once we have 8, what would be our remainder? Miss Aubrey? 1. It would be 1. Now, I explained to you guys yesterday, there's a quick way to check our math on this, okay? We have 33 divided by 4. We say it is 8 with a remainder of 1. We can check that by going in reverse order. We can multiply our quotient by our denominator. What is 8 times 4? Tim? Or Aiden? What's 8 times 4? I know, and don't be talking to friends. It looked like you were just staring at Tim, not this way. So make sure we're looking that's close. I like it because it looks like you're either counting by 4s or 8s. 2 times 8 is 16. 32. Thank you, Aiden. So this is 32. Now, is this the 33 that we're supposed to have? What do we have to do? We had to add our remainder back. Plus 1, 33. Oops. I got a little too close. I know, I got a little too close. I got a little too excited. 33. So, when we look at this, if we can get back to our numerator using this formula, multiplying the quotient by the denominator and adding back the remainder, we will get our number, 33. So is 8 remainder 1 the correct answer? Yes, it is. Go ahead and hand your erase that whiteboard's off, guys. One second, I gotta check my next slide. That should be the case. 1 second, go ahead. Yes, sir.
I did all of them.
You did fantastic. We're gonna keep working on it, all right, sir? We'll use that opportunity. Can I please get tables 1 and 2 to the carpet with whiteboards, markers, and erasers? Since we don't have a word problem today, guys, we're going to do some whiteboard work at the carpet. I know it's a little different. Usually we have an application problem or a word problem. This lesson does not have one. Can I please get tables 3, 4, Braxton, and Crosby to the carpet? Don't forget your whiteboard marker and eraser, guys. It's going to be short and sweet. Ooh. All right, guys. Mr. Carter, make sure you're sitting up on your boxer so I don't step on you while you're laying down. Yes. So, first question, guys. Make sure we're all making it. Yep, Aiden, if you can't sit over here, go take a side. That way you don't have to walk through friends. So Mr. Aiden, come sit right in front of Tessa. So, we see this up here, and I like having my friends read for me so we know what the expectation is. Miss Aubrey, can you read that question for me? 6 ones represents what? Do we have that answer? What does it represent? Right? What does 6 represent in this question? Mr. Henry. Huh? Not what you're dividing by. What you're dividing by is right here. That's your denominator. Is your 3, so that's the size of groups you want to break things into. What does the 6 represent, though? The numerator, or the whole, right? So this is our numerator, or whole. Numerator, that's just a fancy name for everything we got. Alright? So if I had to say, you know, we have a classroom of 19 students, I want to break them into groups of 3, right? Our 3 would be our denominator. Our 19, our whole, would be the group size that we have to work with. That's what we're pulling these groups out of. All right, guys? That's what 6 represents in this equation. Can I have someone please read the next 2 sentences for me, Miss Cassie? Everyone should show me a place value chart with 1s and 10s. And show me 6 discs. Okay? 1s and 10s. I should see everyone making 6 discs. Now, then it asks us a question. What is the number we're dividing by? I see one hand up. What is the number we're dividing by, Crosby? Not 2. 3. Right? Our denominator. Perfect. I'm going to go change the slides. We keep going. Now this shows us how using place value charts, we can break those, much like we did an array, into our answer. I'm going to read this one for us, okay guys? Let's assume it's telling us how many groups to make. That's what it told us, right? So we want to be making groups of 3. So that's exactly what we're going to do. Draw 3 groups below, which is already has it here. I don't want you guys to do this part. I just want you guys to follow along. Can we distribute 6 1s into 3 groups? Think of it like dealing cards, evenly among 3 players. Absolutely we can. How many does each group have? Pardon? 2. That's exactly right. 1, 2, 3, and each group is 2. Alright guys, these are going to be visuals that if you struggle to remind yourself, say, Mr. Hefner, I just don't see it. These arrays and these these place value charts are going to be super helpful for you guys to be able to break these problems down into smaller, more, I want to put this, I almost lost my train of thought, into smaller, more digestible things that you can see. You can see how it's broken down in the problem. Okay? So, go ahead and erase that real quick. Make sure we're not doodling, guys, even though I appreciate the fantastic looking drawings. We keep going. So, when we get here, I'm stopping at this part because this is another form that shows you the same exact problem. So, when we get 6 divided by 3, we all understand that this is our larger number, our numerator. This is our denominator. We're asking you to break a group of 6 into groups of 3, right? We understand that. This is saying the exact same thing, but it's preparing us to do longer division. As the numbers get larger, we're going to be using this as per standard algorithm, okay? Like we use for multiplication, stack and attack. This is how we will stack and attack division when we start to do standard algorithm, okay? It's going to seem like going from using the place value chart or our arrays, much like multiplication, we use our area models and our boxes. That's exactly what this is going to be, okay guys? So this is the same thing as this. I want you guys to all recognize that, okay? When we look up at this problem, this is 6 divided by 3. This is also 6 divided by 3. Okay? Mr. Henry. And that's alright. So I appreciate that you say that. Sometimes this does make more sense for people. We want to see how many times this number can go into that number. Okay? Visually, this is what I like to see for my division as well. That's because I've gotten a lot more practice with it. And instead of doing the arrays or simple mental math, if I need a platform to do more work, it feels more open. It allows me to see it easier. So I like that you mentioned that, Mr. Henry. I feel the same way about it. We keep going. Now, 36 divided by 3. Can I have someone read that sentence for me? Miss Chloe. Make room for 3 groups below. Okay? So, when we see this, I want everyone to draw a place value chart that looks like this. We understand that this is showing us 36 divided by 3. It asks us, what are we dividing by? When we see this problem, what are we dividing by, guys? Miss Aubrey. 3. When we see 36 divided by 3, we are dividing by 3. That's it. When we see this in this form, it is going to look like this, 36 divided by 3. Just to get in the habit of seeing it both ways, okay? I'm going to continue. Just make sure you're following along, guys. Doing great. Let's start dividing using the largest unit. What's the largest unit we have here? Tens and ones. Miss Tessa. Ooh, is that the largest unit? That's the one that we have the most of, so that can be a little tricky, but you're absolutely right, okay? So we have the most ones, but our largest unit is tens. We must start using our largest unit and make sure that it's tens. Now, I don't want to get too ahead of myself. I'm pretty sure that I know exactly what they're going into. So, this is my favorite part about using the place value chart. Okay? So what they did here, all we have to do is ask ourselves this. They showed us something that is absolutely fantastic. Instead of drawing an array that has us making, make sure you find the seed, that has us making 36 little dots, we can do something a little bit easier. What they showed us here is we can start with our place value. Does everyone have a place value chart showing 36? Right? 3 tens, 6 ones. So, what we can do is something very, very special, which is why I love introducing the place value chart to start off. How many times can 3 go into 3? Is that simple? 1, right? We have 1, 1, 1. So we know that should be 1. Then we ask ourselves, do we have anything left over? We've covered all of our 10s, correct? We look to our 1s. How many times can 3 go into 6? They've broken it up for us already. How many times, Carl? 2. Yes, sir. Now, Mr. Aiden, make sure we hold on to that, sir. Just wait. When we come up here, now we can ask ourselves, that was so much easier than making an array. We can simply ask ourselves, okay, how many times does 3 go into our 10s? How many times, and if there's anything left over, we'll just show you that next problem. But then, there's nothing left over. How many times does 3 go into 6? 2. Can someone please tell me what 36 divided by 3 is? Just based on that simple place value chart that we showed. Miss Tessa. 12. That's exactly it. When we start using larger numbers and we use a place value chart, we can approach it just like we did in multiplication, wanting to multiply single digit by single digit. We do the same thing with division, but in reverse. We start at the largest place value being 10s in this problem, and we divided them. So how many 10s and 1s are in each of our 3 groups? We just took care of it. We have 1 10, 2 1s. Our answer is 12. Alright, guys? So I'm really hoping, and I'm pretty sure that's how the slides are set up, this next one should have a remainder, which is going to be awesome to show you guys. So check this out. If I'm not mistaken, nope, we got that, we got that. Nope. So, nope, I want to use a larger one. I want to use a larger problem for that example. There we go. Now I would like everybody This is going to be the last slide that I show, okay? And then we're going to get into our problem set. So watch how we set this one up, guys. Everybody, go ahead and erase off your whiteboards. This is going to be the last problem that we do today, okay? Take care. We're going to do a problem set, but this is the last one that we're going to do on whiteboards. I'm going to send you guys back to your seats and we'll do a problem set, okay? So, we have 45 divided by 4, and I'm going to put it over here as well. 45 divided by 4 can also be written as 45 divided by 4. We also can set up the place value chart. Ones, tens. How many tens? Henry? 4. 1, 2, 3, 4. How many ones, Izzy? 4 tens. How many ones? 5. 1, 2, 3, 4, 5. Now, what I like to do to add one more step to make it easier for me to visualize, much like I do when I make my arrays, our denominator, the number we are dividing by, I like to send it out over here, right? So I know, I ask myself, we have to start with the largest value, largest place value when we're dividing, which is what? What's our largest place value in this problem? Ones or tens? Aiden? What's the largest place value? Not which one has the most. What's the largest place value? Tens. Yeah, you're right. Tens. So we're going to start with the tens. We're dividing by 4. We ask ourselves, how many times can 4 go into 4? Henry? 1. If we were to divide that up, 1, 2, 3, 4. My goodness, that is 1. We go over to the next problem. We see that we are dividing by 4. How many times can 4 go into 5? Crosby? Once. I'm going to make sure I cross these off to show that I've used them. 1, 2, 3, 4. 1, 2, 3, 4. 1. Now, we have a problem. What do we have? Does that go? We have a remainder. This little guy. Trying to cause a problem. We know that 4 can go into 45 11 times evenly, but there's something extra. There's something left. Our remainder. So we know that 45 divided by 4 is 11 with the remainder of 1. Alright, guys? Raise your hand if you like how this works. The place value. How we can use the larger place values and slowly divide into one unit at a time, much like we did multiplication. That's fantastic. Those of you that don't like it, we're just going to get some practice with it today. I'm going to hand out our problem set, and we'll take care of business. Okay, guys? I would like Braxton, Crosby, and tables 1 and 2 head back to your seats. You're not always last. Maybe today you've been last. He's not asleep. No one can sleep through that much talking. So I know that he is trying to avoid some work, but we'll handle that just again. And can I please have tables 3 and 4? Because if we want to be able to make it to art, once you get back to your seat, I would like you. Oh, class. I want it quiet. Once you get back to your seat, Carter Easton. Once you get back to your seat, I would like you to take out your problem set. We are on. I'll get you. I know you weren't here, Mr. Crosby. We are on problem set 16. You will notice they had this set up exactly how we just got doing it. I'm going to leave this up here as an example. Walking around, helping friends out. Make sure we are getting on problem set 16. I want you to do problems 1 and 2. I'll get you one. I know I had friends that were sick yesterday. All right. I got you in just 1 second, sir. All right, Miss Anita. I'll be walking around helping friends solve this. It's a little backwards on my phone. It's going to work out great. Problem set 16. Just doing 2 simple division problems. Again, thank you for everything. I'm a little upset, not upset, a little sad, a little happy that this is definitely the last video. Hopefully the last video that I'm sending to you. Have a great day. Have a happy holiday season. You guys can actually say Merry Christmas, Miss Anita.
Merry Christmas!
All right, I'm gonna walk around and help these guys out. You have a fantastic day. Bye.